Hi, Chapter 15 of Young and Freedman's University of Physics is on mechanical waves, and the introduction and the first section get us going with some basic concepts and definitions. 15.1 is on types of mechanical waves. So, a mechanical wave is a wave that propagates, that is, it travels in some material. We call that material a medium. It could be a jumping rope, a string medium, boing, 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 boing. Could be waves in the ocean, could be waves in the air, sound waves, and so forth. There are waves that aren't in a medium, like light or radio waves, but this chapter is on mechanical waves that propagate through a medium. So, waves carry energy as they propagate. You may have heard of interference patterns. So if you take two stones and you drop them into a pond next to each other, both of the stones will create waves, but when those waves come to each other, they will have an interference between the two waves, and basically where they're above where they were at equilibrium, it'll get bigger. When they're below, it'll get smaller. Anyway, the kind of adding of them, superpositioning, as it were, of the waves. That's something that will come in later. Sinusoidal waves are waves that can be described using a sine or a cosine function. And again, if you don't remember or know what a sine or cosine wave is, it's basically an up and down and up and down and up and down. Think of dropping a stone in a pond. That's basically a sine wave. Or a cosine wave that it creates. Now, as I said, not all waves are mechanical. Light is not a mechanical wave. There was investigation in the 1800s, or thought that there might be some ether that light, propagates through, but it turned out not. Okay, so types of mechanical waves. First of all, we can speak of transverse waves. The kinds of waves that I've been using as examples are up and down waves. So a transverse wave is an up and down wave, a wave whose displacement is perpendicular. So if the wave is traveling this way, it's a perpendicular up and down wave. The other kind of wave is a longitudinal wave. A longitudinal wave is kind of a back and forth wave. So let's say you have a piston, in an engine. Although that really doesn't, that's a different kind of thing, so bad example. But if you think of something that's going up and down, where the particles of the medium are compressing and stretching, as it were, so as the wave moves through the water or whatever, it gets compressed, and then it gets stretched, and then it gets compressed, and then it gets stretched. So that's a longitudinal wave, where the wave is basically moving in the same direction as the wave is traveling. So that's the difference between a transverse wave, up and down wave, and a longitudinal wave, which is a back and forth wave, so to speak. And I don't mean back and forth as in that it moves back and forth, but rather that it has areas of compression and areas of what we call rarefaction. Okay, and of course it can be a both and. You can have a wave that is both moving longitudinally in some way and up and down. Okay, so there you have it, the two basic kinds of mechanical waves. So these sorts of waves propagate with a definite speed. So the speed, now it's important to know that it's not actually the medium that is moving. So the water, when you drop a stone in the pond down here, the water itself isn't moving. It's the energy that's moving through the water. So the water at any one point is just going, say, up and down. It's not going. So when we talk about the speed of the wave, we're not talking about the speed that the water is moving. We're talking the speed that the wave is moving through the water, that the energy is moving through the water, and we call that the speed of propagation, or the wave speed. Like I said, the medium itself does not travel. It's the pattern in the medium that travels. I mean, in a stadium, when we do the wave, that's a transverse wave. And the people don't, it's not the people that move, but it's the energy, as it were, that goes up and down throughout the stadium. And in order to set the wave in motion, energy has to be put in. So again, it's energy traveling through. So waves transport energy. They don't transport matter from one place to another. Well, there you have it. That's the beginning of mechanical waves in this new chapter in Young and Freedman's University Physics.